Today's section 1-2, slopes and intercepts. You can see today's learning goal. You want to be able to graph a linear equation, write a linear equation for a given line in the coordinate plane. Slope is known also as a gradient. I believe our textbook does not call it that, but it's just another word in your vocabulary that you can have to show gradients. Slope is known as your change in y over your change in x. Some of you have learned the equation y minus y over x minus x. In a graph, you look for your y-intercept, place a point, and you look for the change in y, which is known as the rise, over the run, in this case, which was only 1 unit, and therefore our slope is 2 over 1, or 2. If you look at these lines, it's not as evident, but for example, in line A, if we were to pick this first one and follow it up and just choose the end point, we would then have to do 1, 2, 3, 4, 5, 6 for my rise, 1, 2, 3, 4, 5 for my run, which would give us a slope of 6 fifths. On line B, if we followed that same method, our point at the end points would be reached. They are both right on intercepts, and that's why they're working intercepts of our graph paper. They look like they're whole number values. If we did this one, we'd have 1, 2, 3, 4, 5, 6 over 1, 2. 6 over 2 reduces to 3 over 1. Now I want you to look carefully that if you would have chosen this point right here that looks like it also has crossed right at an intersect, we would be able to count 1, 2, 3, and over 1, and then at that 3 over 1 much quicker than the other way. So the quickest way you can get there is obviously more efficient. Pick another one out here and just try it and see if you can find one. We're going to pick, for example, line G. If you look, line G does not have both ends being exactly on an intersection. The top one does appear that way, but if you look through it, the bottom does not. But if you look about 2/3 the way down, you can see that point does. So again, in this case, we would be going 1, 2, 3, 4, and it's a -4 because we're going down, and over 1, so we'd end up with a -4 over 1, or -4 for our slope. Should be able to get all of those. If you have any questions on any of them, bring those as part of our discussion for class. Some of the notes that you might want to take or have taken after the reading. Remember that standard form of a linear equation is ax plus by equals c, an equation you learned in Algebra 1, where a and b cannot both be 0 at the same time. If they were, it would wipe out the whole entire left-hand side of the equation, and you would get 0 equals c, and 0 equals c is 0 equals a number, which is not a true statement. Slope-intercept form of a linear equation is y equals mx plus b, where m represents the slope and b represents the y-intercept, again, used often in Algebra 1. The slope of a horizontal line, y equals b is its standard form of its equation, is 0. And I want you to, again, remind yourself why. Horizontal, same as the horizon. If you pick 2 points on any horizontal line, and you ask yourself the same thing, what is the rise over the run? We're not rising at all, so that's a big fat 0. And we can run however many points this is. Let's say it's 4. If we do 0 divided by 4, we will get an answer of 0. Vertical line, again, think through it. If you pick any 2 points off of a vertical line, and we do the rise over the run, There definitely is a rise, so maybe a 3 in this case, but there is definitely no run. Therefore, this is impossible because you cannot divide by 0, and so all vertical lines have undefined, or we also say no slope. A few other things with slope. Slope represents steepness of a line, especially in story problems. We like to think of it as the rate of change. Rise over run is a good way for graphing. The rise is the change in the y, the x values. The run is the change in the, said that backwards. The rise is the change in y values. The run is the change in the x values. You can count the slope on a graph, or you can use the formula, again, that was used in Algebra 1. Change in y's over change in x's, which is y2 minus y1 over x2 minus x1. Order really does not matter as long as you're consistent. So you could do the y1s first and the x1s first if you are just consistent in your setup. Reading left to right on a graph, lines that have a positive slope slant up from left to right, lines that fall have a negative slope. Slope is always represented by a fully reduced fraction, but never by a mixed number. We like a proper fraction, maybe like 3/4. We like an improper fraction, like 8/7. But we do not like you to change that to a mixed number. Slope is two values. It's a ratio. Y equals mx plus b is your slope-intercept equation, again from Algebra 1. Two discussion points for tomorrow's class you need to think about. Maybe write some answers down so you'll have them when we discuss it. What happens when you vary m? What happens when you vary the slope? And what happens when you vary b? So keeping the other item the same, what happens when you would change and use positive, negative, fractions, zeros? Use all of the above in your hypothesis ready for discussion. Standard form, something you definitely have seen before. And with some numbers in, it might look like this: 3x plus 2y equals 4. In generic form, though, when we replace none of the numbers and we keep it all the letters, we have ax plus by equals c. And if we were asking you to change this to slope-intercept form, you would have to get y by itself. So in doing that, in generic form, we would first move that ax term to the other side by adding its opposite. From there, we would have to divide by the b value and reduce, and we would end up with y equals c over b minus ax over b. You can also rewrite that so it matches slope-intercept form exactly. In other words, y equals mx plus b is supposed to be our form. We do not have the slope first, so if we just rewrite it, switch them around, y equals the opposite of ax over b plus c over b, which then corresponds to a shortcut we're going to be able to use. Notice, in standard form, every single time, that opposite of a over b represents our slope. So we will be able to say that in standard form, slope is opposite of a over b. The y-intercept, same thing, has a shortcut of c over b. So we would be able to go back to our original equation and say, what is it, without having to rewrite it. But lastly, the one question not answered here is, what is the x-intercept? In slope-intercept form, we really only discuss the slope and the y-intercept. We should also have another shortcut for the x-intercept. So let's explore a little further. Since all x-intercepts are in the form x comma 0, any x-intercept on the axis on the x-axis, any of these points are in the form of x0. So we'll place a 0 into our standard form of our equation, and we will solve it. So in other words, x equals c over a, which is our third and final shortcut. And putting them all in perspective, we can now say that the slope in standard form is equal to the opposite of a over b. The y-intercept in standard form equals c over b. And the x-intercept equals c over a. 3 shortcuts you're going to be able to use. It will definitely eliminate having to rewrite your standard form to slope-intercept every single time. And going back to the equation we had up there, I believe it was 3x plus 2y equals 4. You would first identify what your a value is, what your b value is, what your c value is in standard form, and then you would place them appropriately according to our shortcuts. So here we go. The slope of this line would be the opposite of a. Well, a is 3, so the opposite is negative 3, over b, which is 2. The y-intercept is c over b, which would be 4 over 2, also known as 2. And the x-intercept is 4 over 3, and we would leave that 4/3. So a shortcut, definitely, taking the equation, not having to rewrite it every single time. So memorize these new shortcuts for standard form to slope-intercept form easily. With that, you should have some questions for me. Come to class with those questions, but should be able to work on the problems as well.